One important thing to understand is the open networks versus the proprietary networks. In fact, we use a solution based in an open concept because the different systems, the different end systems, and the different intermediate systems, like those, are provided by different vendors. Then we need, in order to implement a solution, an open solution like this, we need to use some standards. For instance, standards to communicate this end system with this intermediate system, or this end system with the other end system across the network. Then we need to establish standards that could be industrial standard or open standard, that is standards established by standardized organizations like International Standardized Organization, ISO. And within some systems, particularly the end systems, we implement an open solution because we could use different components within the end systems that are provided by different vendors. That's why we need to establish different layers with different functions and with some interfaces between layers. Then we are talking previously about the importance to implement open solutions in the network and systems fields. That is, this end system could be provided by one vendor different from this other end system, and this intermediate system could be provided by a vendor different from the end systems and perhaps different from other intermediate systems that we need in the network. And then the layer-oriented network architecture is based in the use of different layers. Each layer implements some functions, some particular function for each layer. The functions are implemented by entities. Each entity dialogue across a protocol with his peer entity in the other end system, or perhaps between intermediate systems, or between end systems and intermediate systems. The protocol, remember that the protocol is a standard that defines the message format and the procedure of exchange of those messages. And in order to implement those functions, the entity exchange protocol messages with the other entity in other system, but collaborate with the entity of a lower layer, because in fact the communication between the pair entities is performed across a virtual communication link. In order to send the protocol messages, an entity needs to interact with the lower layer, the layer below, across a service interface. And then in that way, the upper layers could send their messages and because they provide their message called typically or generally protocol data unit, and they they bring the message to the lower entities until the lowest layer entity could transmit the message protocol across a physical link. In that way, and this mechanism is based in a concept of encapsulation. That is, the PDUs, the protocol data units of each layer, is encapsulated in the payload of the PDUs of the lower layer, and so on. When a message protocol arrives to the end system, each layer decapsulates the message contained in the payload of his PDU, and bring the message to the upper layer, and in that way we could see or we could achieve the goal to exchange message protocols between the entities, the pair entities, as those pair entities were communicated across a direct link. Then we were talking about layers, entities, functions, protocols, and service interfaces. What is important to know is that there is another terminology that we frequently use, that is architecture and model. When we talk about a network model, we are talking about the definition of layers, how many layers, what name has each layer, and functions, the functionalities that we assign to each level, to each layer. And in the case of architecture, we talk about an architecture that is defined based in a network model, and this architecture defines a set of protocols and service interfaces.